The addition rule gives us a way to find probabilities such as the probability of A or B. When we say A or B, this is a compound event. It's any event that combines two or more simple events. The compound event A or B is the event that A occurs or B occurs, or that they both occur. The probability of A or B is the probability in a single trial event A occurs or event B occurs, or they both occur. To find this probability, we first need to find the total of number of ways that A can occur and the total number of ways that B can occur without counting any outcomes more than once. Here's an example. 1,000 survey responses are collected. The results are, as you see in this table. So we have gender, and then we have 3 different age groups. So if one person is randomly selected from the 1,000 survey respondents, find the probability of selecting someone who is male or over 65. So to do this, we need to find the total number of respondents that were male or over 65 without counting any of them twice. One way we can do this is to mark the cells for respondents who were male or over 65 and then just add the numbers in those cells. So if we look at all the cells for the male row, we've got 123, 275, and 113. Now we also need to count the respondents who are over 65. We already counted the 113 in this cell, so we don't want to add that one in again because we don't want to count anyone twice. So we're going to add on the 202 that were over 65 but female. So we're just adding the numbers from these 4 cells together, and that gives us 733. The other way we can do this is to add the total of the male row, so the 531, and we can add that to the total of the over 65 column, which is the 315. Now when we did that, we actually counted the ones in the intersection of that row and column twice. So these 113 people here got counted twice. So we have to subtract that 113 out so that it only gets counted once. So if we add those two totals together and then subtract the 113, we also get 733, which matches what we got doing it the other way. So either way we do it, we find that there are 733 responses out of these that were male or over 65. So the probability of selecting someone who's male or over 65 would be 733 divided by the 1,000 total responses, and that would give us 0.733, or 73.3%. Now let's talk about disjoint events. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, they have no outcomes in common. They don't overlap at all. So here's a picture of 2 events that do have an overlap. Notice we've got 2 circles here. We've got an overlap in the middle. So these 2 events are not disjoint. These 2 events are disjoint because they don't have any overlap. So in a situation where we have disjoint events, to find probabilities, we can just add the 2 probabilities together if we want the probability of A or B. If we have an overlap between the 2 events, then we can still add the 2 probabilities together, but again, the part in the overlap gets counted twice when we do that, so we have to subtract that value out in order for the overlap to only get counted once. Okay, let's go back to our example with the survey responses. Now, if one person is randomly selected from the 1,000 survey respondents, find the probability of selecting someone who is under 18 or over 65. So again, we need to find the total number of respondents that were under 18 or over 65 without counting any of them twice. So let's say that event A is selecting someone who's under 18, and event B is selecting someone who is over 65. In this case, A and B can't occur at the same time because no one can be both under 18 and over 65. So there's no overlap, and these are disjoint events. So to find the probability of A or B, we can just add the totals for the under 18 and the over 65. Since they're disjoint, we won't be counting anything twice. So we could just take the total of the under 18 column and the over 65 column and add those two together. That gives us a total of 487 responses. So our probability is 487 divided by 1,000, or 0.487.